Again, welcome to Database Management System course. In these lectures, we're going to learn about entity relationship modeling, ER modeling. This is our Unit 4 lectures in our database management course. So our main objective in this course, hopefully after we complete these lectures, we will be able to identify the main characteristics of entity relationship components. And the main characteristics, again, are the attributes and the relationships, and we may go details on them. Also, we're going to describe how relationships between entities are defined or refined and also incorporated into the database design process. Also, we are going to see how the ERD, which is the entity relationship diagram, ERD, components affect database design and implementation. Also, we are going to understand the real-world database design often require the reconciliation of conflicting goals. Also, we are going to use an example of a university database system, how we identify all the entities and the relationship between the entities. For example, in a university, one of the entities can be a student, another entity can be the professors, another entity can be the course. Each entity have its own attributes. The attributes will be the characteristics of the entities, and we may have the data type of each attribute. For example, in a student last name will be a test. Student's grade can be a test, which is A, B, C, D. But a student score, let's say exam score, will be a value or numerical value. So we may go through that. And also, as we discussed in the previous lectures, in a database management system, the process of design and developing a database, the first thing is to come up with the organization's business rules. The business rule, for example, in a university may say that one professor can teach only one class at a time, or one professor can teach 1 to 4 classes at a time. This business law will give us the type of relationship we are going to have between, again, a professor and the course. Most of the time, the relationship here will be the verb, teach, or a student can take one or more classes. So again, we may go through these details. So we start with the entity relationship model. We say this form the basis of entity relationship diagram. The entity relationship model will be a conceptual database design concept. So we know that a database main components, again, are the entities, the attributes, and the relationships. So entity relationship diagram always may consist of entities and the relationships. Each entities will have the attributes. The characteristics of an entities are the attributes. So we start with the entities. Entities here we say is the object of interest to the end user. So an example of an entity can be a customer, it can be a student, it can be an inventory. So it's an object of interest. So refers to the entity set and not to a single entity occurrence. Now, ERM, which stands for Entity Relationship Model, normally corresponds to a table, not to a row in a relational environment. So a ERM normally refers to a table row as an entity instance or entity occurrence. So again, in database system, we have 3 different types of notation. The most common notation we use is the UML, which is Unified Modeling Language. We even use the UML in software engineering. There are over 14 different diagrams, notations. So in database system, again, we have the chain model. We will see it in a few minutes. Also the Crown's fit and the UML notations. So those are, again, there's a difference between these 3 notations. So one thing also we should remember, anytime we identify entity, the name of the entity should be a noun. From the definition, we say entity is an object of interest to any user. So an object should be a noun. So example, a student, inventory, product, they are all, the name is noun. So the attributes again are the characteristics of the entities. So required attribute means we must have that attribute. For example, in a primary key field, always we need a value. So a required attribute. For example, student attribute. One of the student's attributes can be the student ID. Student ID is a required attribute because we can have the student ID as a primary key field or primary key attribute. A primary key attribute is a unique field that identifies each record. So two students cannot have the same student ID, but last name, first name, and even address. Two or more students can have the same address. They can live in the same address, or their name can be the same. So a required attribute means we must always have a value and it cannot be left empty. And a good example will be the primary key field, because the primary key field or attributes, a primary key attribute normally uniquely identify each record. And we may have optional attributes. Optional attribute does not require value, so we can leave it empty. Also, we may have a domain of an attribute. So that would be the set of values for a given attribute. Let's say a domain of an attribute for age. It can be maybe from 0 to 150. Maybe in a real way, only few people may live up to 150 years. So let's say 120 years. But we cannot have a domain of an age from 0 to 1,000. There's no way a person can live up to 1,000 years. Also, we may have identifier. The term identifier is when we have one or more attributes that uniquely identify each entity instance. So this is the concept of primary key field. We also have the composite identifier. Composite means you have two attributes that may uniquely identify each record. So that's why it's called composite, more than one. So a composite identifier will be a primary key composed of more than one attribute. So we may use the student ID or maybe student last name and first name together as a unique field, because two students cannot have the same first name and last name. Again, it's possible. This is just an example I'm giving. We also have a simple attribute. That means attributes that cannot be subdivided. So example would be, we have attribute for name. A name can be subdivided as last name and first name, but a last name will be a simple attribute because we cannot subdivide a last name. Also, a single value attribute, that means attribute that has only a single value. So this example of attributes, and this is using the chain model, as we said. In a chain model, we have the entity as a rectangle in the middle, and each oval is the attributes of the entity. So a student may have a student last name, student first name, student initial, student email, and also student phone number. So all the 5 ovals are the attributes of a student entity. So we may use the term the characteristics of a model is the attributes. So attributes are the characteristics of a model. Normally, the chain model is not implemented in a software system. It's not common. The next one is the Crown's fit model. It's the same information we have, but here we can see we have only one box. The first row will be the entity name. Then the second row will be all the attributes. So we have the same 5 attributes. So student name, first name, last name, initial, email, and phone number. So this is again an attributes with the attributes are the 5 attributes and then the entity student. So another example here, we have a car attribute. Then we have the car VIN, the VIN number. Now the underline means it's a unique field. So that's the primary key field. 2 cars cannot have the same VIN number. So always when we have an entity, we have to have one attribute of the entity that will make that very object uniquely. Otherwise, for example, we have an Amazon database system. They have millions of customers around the world. If we don't have any unique field, we can repeat the same customer anytime the customer buys something. We can repeat this information over and over again. Or even the employees. Amazon may have over 1,000 employees. If 2 employees have the same name, or even if we don't have any field to uniquely identify each record in the database or each employee in the database system, we may end up having entered the same employee more than once. This will cause waste of time and also consume a lot of computer resources, such as storage and memory also. So the car VIN number will be the primary key field. This will make sure that we do not enter the same car entity or object more than once. And the crans field is the same. We have the box and we have the rectangle again. We also underline the primary key field. Then the rest of the attribute like model code, the car year, and the car color. 2 cars can have the same color. More than 2 cars are manufactured in a year. And more than 2 cars can have the same model code. But the VIN number is uniquely among all the cars. So there's a requirement also for a multi-value attributes. A multi-value attribute means, again, we have attributes with more than 1 value. So here we're going to create several new attributes, one for each component of the original multi-value attribute. Then we develop a new entity composed of the original multi-value attribute components. We can also derive an attribute. A derived attribute is attribute whose value is calculated from other attributes. So an example would be, let's say we have attribute for salary. We have attribute for number of hours you work. We have an attribute for hourly rate. So to find the attribute of salary, we can multiply the previous 2 attributes, which is the hourly rate times the number of hours, and that will give us the value for salary attribute. So a derived attribute means the attribute value is calculated from other attributes. So this is an example of another, the car model again. So here we have more attributes, but the whole concept here is splitting the multi-value attribute into new attributes. So we were talking previously, we are talking about the car color. Now you can see that we split it to 3 different types. We still have the car VIN number, which is our primary key field. We still have the model code. We have the car year. But you can see that instead of saying the car color, we have 3 different types. So we have the top color, trim color, and body color. Because a car may have more than 1 color for the whole car. Maybe the top color may be different from the trim or from the whole body. So this is the concept again. Instead of using one multi-value attribute, we break it into 3 values attributes. So now the car top color will be only 1 color. The car trim color will be only 1 color, and then the body color will be only 1 color. And also we have an example of employee, and we are going to derive attributes. So here, employee number, we didn't underline it here, but the employee number will be the primary key field. Last name, first name, initial, date of birth, and also employee age. Now, if we have employee hourly rate and number of hours work, we can also have a salary as derived. But here we're going to use the employee age. Now, if we know the date of birth of the employee and we know today's date, then we can know the employee age. So we are not going to ask the employee age. Employee age is already based on we ask the employee date of birth. So automatically the age will be updated every year. So employee age is a derived attribute. It's based on the present today's date and the employee date of birth may determine. So what are the advantage and disadvantage of storing derived attributes? So here we say the derived attribute, we need to store it. Again, we have to use some algorithm to calculate it. So the advantage is that it saves CPU processing cycles, and also it saves data processing time. And also data value is readily available, can be used to keep track of historical data. Example for the age, every year the age will be automatically updated based on the present age, present date, and the date of birth. But the disadvantage is that we always have to make sure the algorithm is working. So it required a constant maintenance to ensure the derived value is current. Now the derived value not stored, these are the stored, the derived value can be two. One can be stored, one is not stored. So not stored derived attributes, normally it will save storage space. Computation always yields the current value. Disadvantage is, again, since it's not, the algorithm is not stored, we need to, again, always find the result process. So the CPU processing cycle will increase. And the time it will take, again, will increase. Now, next, so we discuss about entity and attributes. Now we go to relationships. As we said earlier, entity relationship model consists of three components: the entity, the attribute, and the relationship. So with relationships, we're going to talk about connectivity also and cardinality. Cardinality is the degree of the relationship, and we will discuss that. So the association between entities that always operate in both directions is called, again, the relationship. So student can take one class. A class is entity, student is entity. The association between the class and student is the relationship, can take one or more classes. And we have the connectivity. The connectivity will describe the relationship classification. We have three types. We have one-to-one. This means one entity can do only one thing. So one student can take one class. One-to-many, one student can take many classes. Many-to-many means many students can take many classes. So these are only the three possible types of relationships. So connectivity will describe the relationship classification, which are these three types. Now, the last section is the cardinality. So cardinality will express the minimum and maximum number of entity occurrences associated with one occurrence or related entity. So in a ERD diagram, cardinality is indicated by placing the appropriate numbers beside the entity using the format X and Y. We will see an example of this, but again, cardinality is the degree of the relationship. We will go through that. So we have existence dependency. Existence dependency means entity exists in the database only when it is associated with another related entity occurrence. Now, as existing Independency means the entity exists apart from all of its related entities. So since there's no dependency here, we will refer this as the strong entity or regular entity. Existing dependency may be called a weak entity. Here, the entity exists in the database only when it's associated with another entity. So a very good example would be an employee. Employee is the person that was employed in a company to work. But also employees have dependents, like spouse, children. The children are not employee of the company. So in this case, the children or the spouse entity is a weak entity because it depends on an existing entity. If the employees stop working for the company, the children will not, or the spouse will not be in the database if the employee is not there. So those are the two types of entity. We have a regular or strong entity, which is existence independency. In this case, the entity existent doesn't depend on any related entities. But dependence, existence dependence means it's a weak entity. The entity exists because another entity is existing. So relationship strength, we have the weak and the strong. So weak is the non-identified relationship. Here, the primary key of the related entity does not contain a primary key component of the parent entity. And the strong one, strong relationship, the primary key of the related entity contains the primary key component of the parent entity. The condition of a weak entity is what we discussed, the existence dependent. If an entity exists because of another entity, we call it a weak entity. So it has a primary key that is partially or totally derived from the parent entity in the relationship. Most of the time in employee case, the employee primary key will be the same as the employee spouse or dependent's primary key field. That's what most organizations do. They will not have a special spouse primary key field, let's say social security number, or if we are using employee ID, if an employee is hired and they gave him ID number, which is uniquely identify each employee in the organization, they are not going to give employee ID, separate employee ID to his spouse or children. So that will be a weak entity. And most of the time, the weak entity primary key field is the same as the entity that it depends on. So database designer determine whether an entity is weak. It will be based on the business rule of the company or the organization. If an organization gives the spouse of the employee a special employee ID card and or separate information, then it's not a weak entity number. So it will be based on the business rule. So we see the chain model here for employee, and actually this is a good example. So we are using employee and dependent. We know the dependent entity existed because of employee. So we say employee has dependent. So we can see that we have a dependent number, employee number, employee last name, first name, etc. Then with the dependent, we still use the employee number. Then we may have the dependent number too, but employee number is very important because in order for the dependent entity to exist, the employee entity must be available. And we have the same diagram for the Crown's fit model. So employee has dependent. So this is an example of a weak entity in a strong relationship. We have the employee and we have the dependent, and we have the necessary information for each employee and the dependent. And one thing we can notice here is that we can see the dependent. We have the employee number 1001, dependent number 1. So that means employee 1001, which is here Califati Jenin, he has two dependents, George and Annalise. So dependent 1, dependent 2. Now, relationship participation, we say the optional participation is when you have one entity occurrence does not require a corresponding entity occurrence in a particular relationship. So that will be optional. If one entity occurrence does not require the corresponding entity occurrence in a particular relationship. But the mandatory participation is one entity occurrence require a corresponding entity occurrence in a particular relationship. So this relationship is mandatory. We have to have it between the two entities. So this is a class optional to course. So here we have one course generates 0 or many classes. So optional, you can see that we start from 0. So if it's 0, that means the course does not have any class. If we make sure that the course must have a class, then we start from 1. So we can say one course generate 1 or many classes. For example, we may have a course CS 101, and we may have up to 10 sections, so many. And maybe in the following next semester, in the summer, we are not going to offer that class. So it can be 0, 1 to 0. When we offer only one class, then 1 to 1. If we offer more than one, then 1 to many. If we don't offer the class in that very particular semester, then it's 1 to 0. So this is the mandatory. We have to start from 1. So the course generate 1 or many classes. Again, optional, it can be 0. When it's 0, then the course does not generate it. So that's optional. But mandatory, we have to have at least 1 class. Then we talk about the relationship degrees. This will indicate the number of entities or participants associated with a relationship. So we may have unary. Unary means 1. Unary. Unary relationship means the association is maintained within a single entity. It's 1 single entity. Binary relationship means we have 2 entities associated. So for example, sometimes we may have, so again, unary means 1. Binary means 2. So example, let's say we have a course. If we have a course entity and there's a relationship within the course entity, which we call the recursive, that will be unary. Now, binary relationship means we have 2 entities, so course and professor. Or ternary relationship means we have 3 entities. Then recursive relationship means relationship exists within the single entity type. So unary and kind of recursive relationship, kind of the same concept. But again, we will go through each example. So unary relationship, association is maintained within single entity. Binary, the association within 2 entities. Ternary, association within 3 entities. And recursive, association exists within a single entity type, which is unary also is a single entity. So this is an example. We can see the unary, we have employee. So we say employee manages employee. So now we will see the difference between recursive and unary. You can see that in unary, employee, we can have different types of employee, but employee is an employee. A supervisor manages the junior employees or junior staff. So within the employee, we have different types, but since they are all one entity employee, we have one. But with recursive, it have to be the same type. That's why let's go back to the definition. We say relationship exists within exists within a single entity type. So if it's only supervisor, supervisor manages supervisor, the same entity. But a single entity for unary, there can be one entity but different categories within. So binary is very straightforward. We have so many examples. So professor teaches a class. This is very common association. Then ternary, we have a doctor prescribes drugs to patients. So we have doctor, drug, and patient, three entities. And the ternary logical, this is again, we put the prescription in the middle. We say doctor writes prescription received by patient or appear in drugs. So with the recursive relationship, we say the relationship can exist between occurrences of the same entity set. They have to be the same. So employee, if we are going to use employee, that means the manager manages self. But with unary, we can say a manager manages junior staff. The entity is employee because a junior staff is an employee. The manager also is an employee. So that would be a unary. Manager manages junior staff. Both of them are employee. But recursive means the manager manages himself or herself. Then that's recursive. So you have to be the same entity set. So we say naturally such a condition is found within a unary relationship. This is common in manufacturing industries. Now, one common pitfall when working with a unary relationship is to confuse the participation with referential integrity. We discussed about the referential integrity. This makes sure that the relationship in terms of updating, deleting, cascading, again, it should be correct. So a recursive relationship, employee is married to, or employee manages, or a course has, so it's within the course itself, it has something. Next, we talk about the associative composite entities. As we said earlier, again, composite means two or more some. Example, like a composite function. So a composite entities is used to represent many to many. MN means many to many relationship between two or more entities. It has one to many relationship with the parent entities. This is normally composed of a primary key attribute of each parent entity. Also, it may contain additional attributes that play no role in connective process. So we can see a composite entity in an ER diagram. We have a student, we have a class, we have enroll. So now the primary key for student is student number. The primary key for class is class code. So enroll have a composite. In order to know what is the student that enroll in a specific class, the enroll entity will tell us. So in the enroll entity, we have the class code and student number as a composite primary key field, then the enroll grade. So this enroll is a composite entity or associative entity. The primary key of class and the student are in a row. So if I go to the enroll entity, I can see the student that enroll in this particular class or in a particular class. So how do we develop a ER diagram? Again, the first thing is we should know the components of ER diagram, which are the entity, the attributes, and the relationships. So first, we create a detailed narrative of the organization description of operation. As we said earlier, the relationship, we can always derive it or know about the relationship through the business rule of the organization. This is the reason why the first option here, they say create a detailed narrative, the organization's description of operation. This will be the business rule. We may have a university saying that one student can take only one class in a semester. Another university can say that one student can take many classes, 2 to 4 classes in a semester. So we need to know the business operation, the description of it. Then if we know the business operation, we are going to identify the business rules based on the descriptions, the business operation description. Now, if we know the business rule, next thing we do is to identify all the possible entities. Let's say an organization have employee, customers, the product they are selling, etc. We identify all these will be the entities: product, employee, customers, suppliers, vendors. All this will be an entity. Then we look at each entity and see what association they may have, the relationship. Now, the relationship between the entities will be based on the business rules. So that's why we were able to identify the business rules first before the entities. Then from there, we are going to develop our initial ERD or the ER diagram. After that, we go back to the entities now. What are the characteristics of the entities? We have to come up with all the possible attributes and also the primary key. Primary key field in database management system is very important because we don't want to enter the same record more than once. So when we identify all the attributes, we may also identify the primary key. Then we have to revise and review the ERD until we make sure there's no error, everything is good. So again, these are the steps. And to summarize these steps, when I want to create a ER diagram is like it's a tool for designing a database system. So we have to design the database system first before we implement it, before we develop it. So the first thing I want to know, I want to understand the organization that I'm developing the database to. So description of the operation, what type of business they are doing. From that, I can know the business rules or get the business rule of the organization. Then we need to identify our entities. Based on the business rule, we can find the association between the entities, that's the relationships. From there, we come up with all the characteristics of the entities, which will be the attributes. Then we identify our primary key field, foreign keys, etc. So this is an example of a tiny college ERD segment. So the college, first we identify the professor identity, professor entity, the school entity, and the department. And we can see the relationship. A professor is a dean of a school, and the school operates the number of departments that they operate. So a school is only one, but it can have more than one department: computer science, mathematics, business department. We may have more than one dean. There's a dean in each department or each school divisions. Next, we know the department may offer some classes. So we can have a relationship between the department and the course. So one department offers 0 or many courses. So this is again optional relationship. We start from 0. Sometimes a department may decide that very semester they are not going to offer no class. Then from there, we have the third tiny college ERD diagram. We come up with the course. We know the class is an entity. The semester we are going to offer the course can be an entity. So we say one semester include how many courses they offer. Maybe a semester in the summer, the school may not offer no class. So it can be 0 or many courses. And also the course, each course can generate more than one session of the class. So one course can have 0 or many classes, which is different sections of the class. Then we also can have a relationship between professor and class. One professor can teach zero or many classes. So sometimes professor may not teach that semester. Sometimes may teach 2 or 3 classes or 1 class. So from 0 to many. If the business rule said a professor must teach a class, actually a professor must teach 2 or more classes, then we have one-to-many relationship. Or we can make it mandatory from 1 to many. Another example, one professor can advise 0 or many students. Again, this is an optional relationship from 0. So sometimes as the semester, a professor may not have students to advise. The school will not assign students for the professor to advise. So again, this is the table to identify all the ERD diagram that we create. So we know there's a relationship, entity school and a department, we have one-to-many relationship. And the relationship name is operate. One student operate, one school operates one or many departments. A school can have only one department or many. A department has one or many students. So a department must have at least a student, one student or many. Employees, department employs many professors. Department offers many courses. So again, these are all the relationships we were able to find from a university or a school organization. So database design challenges, sometimes the main is the conflicting goals. Database designers must often make design compromises that are triggered by conflicting goals. These goals are, again, the business organization goal. So as a database design must conform to the design standard. And also high processing speed may limit the number and complexity of logically desirable relationships. Maximum information generation may lead to loss of clean design structures and high transaction speed. This will lead us to normalization concept, which we will study in the next 2 videos, next 2 chapters. So in short here, in this course, we learned about the entity relationship model. This is the first step in database design process before the implementation. So when we get the ER diagram together, it means we have identified our entity, our relationships, our attributes. Then next section, we have to come up with our relational model, the table. So we come up with the table. Now we have to go details about each of the attributes. What is the attribute data type? How many characters of the largest value we can enter there? We have to explain that in each attribute. Then from there, we have to start our normalization. Normalization process is either we are going to have more table. For example, one table will not be normalized. Again, we will discuss, this is a special topic by itself. So when we get to normalization and we normalize all our table, maybe anytime we move from first to second normal form, we are going to get more tables. We are going to break 2 tables and 1 table into 2, etc. And then after we normalize the whole table, then we are ready for implementation. Here we can use the sequential query language or structure query language, SQL, to again implement our database system, either using MySQL, which is again open source free, or you can use Oracle, Microsoft Access, etc. We have different types of, again, database management system software that we can use to implement. So again, this will be the conclusion of our lectures. These lectures cover the entity relationship modeling. The next lecture, we will go through normalization process. So again, wish everybody the best and thank you.